Just want to set the stage today. What we're going to do is primarily look at how has streaming analytics changed from where it started a few years back to what it is right now, and primarily look at case studies from Uber, Razorpay, which is a very big payment gateway back in India, and then Stripe, right, the biggest payment processor across the world. So bear with me. We'll try to take a small journey to what has been to what these, let's say, native digital natives are doing today in the world of real time analytics, stream analytics, right? So I'm not sure if somebody would have looked at this, but this is what Stripe had built live microsite, right? So this is during their last Black Friday sale around November, same time, right? This is basically a microsite that they built to track the live number of transactions that are happening. What is their API uptime looking like? How many transactions are going through per minute? What is the accumulated value? So on and so forth, right? And these were live numbers, and this microsite in itself became a huge marketing play for them uh, during the Black Friday sale, right, in terms of how Stripe was doing the business and how it was going about it. This is one example of it, right? Moving ahead, this is basically Uber powering these multiple experiences, right? So for example, when you search on Uber Eats to find out, give me pizza restaurants within 5 mile radius of my location, or when you're searching for certain surge pricing within your core Uber app, or even when the driver app, which is used by the Uber driver partners, looks at the surge pricing associated, right? These are some of the hotspots you can see, which are basically micro aggregations or micro, I would say, analytics, which are happening within the app itself, right? Which is helping Uber create these magical experiences across. And then on the other side, what we have is Razorpay, right? So Razorpay does something which is known as success rate. So as Razorpay is a payment processor in India, so what it does is it gives a real-time view of basically the success rate for each and every payment instrument. Like, so what does the payment success rate for cards look like? What does it look like for net banking? What does it look like for UPI? Back to the merchants, right? These are again analytics which is being done in real time, powered back to the users, which is their merchants in this case, right? This is actually giving analytics back to their end users, both in case of Stripe, Uber, as well as in Razorpay, right? So these are some of the experiences which these, let's say, digital native giants have managed to create, right? And we want to peel back and look at what does it mean? Why do they do this, right? Why do these digital native startups or these behemoths care for what we call as fast analytics, right? For this, what we want to do is understand that what is the value of data, right? So as and when a single event is happening, that value of that event is paramount, right? You want to immediately know when a Uber ride was booked, or you want to immediately know when a Stripe transaction was happening, or similarly a Razorpay transaction, right? So a value of that particular transaction happening in real time is pretty important. However, as time moves ahead, the value of that single transaction becomes less important, and the value of aggregates of those transactions over past 1 month, 1 day, 1 hour, etc. becomes important, right? Hence, what you will see is data has a natural half life, right? Similar to any radioactive element, if I may. Basically, the value of a transaction when it has actually happened within that particular minute or within that particular second is pretty high. However, the value of that single transaction declines over time, and the value of aggregate of that data keeps going on increasing, right? So you want to be able to capture that value when and where it happens, right? And that brings us to the problem of real time analytics, right? To be able to capture or get that data in real time primarily. However, there are certain challenges with doing this in real time, right? Primarily, if you think of any analytical system, you want to think about in these three dimensions, right? One is the freshness. So freshness means the data freshness here. How fresh is your data, right? When an event is happening in the real world, how quickly are you able to generate a digital event out of it or a digital twin out of it, and allow that event be available for processing for analytical purposes, not just for your transactional purposes, but for your analytical purposes. Again, traditionally, the data freshness depended upon your ETL pipelines, right? It might take, it started from anywhere plus doing from T plus one to doing more minute base to eventually, however, these systems needing second base, right? As I mentioned, the value of the data being per second. So, for example, LinkedIn does this beautifully again, right? If I go ahead and look at your profile right now, and event is generated, that event is propagated further, and you get an immediate notification. And if you look at who's viewed your profile, you will see an immediate bump in one of the graphs, right? We cannot wait for multiple hours for just for that event pipeline to complete. Hence, the real time nature, that is the data freshness, becomes a paramount activity. The second dimension of thinking about this real time analytics is in terms of latency, right? Since these applications are now powered within the core applications itself, right? We like to call them as data apps, which are within the core applications, right? Similar example, the merchant dashboards within the Stripe application, or the Uber Eats application that we saw, or even the Who's Viewed My Profile within LinkedIn, right? These are core part of the product, and users, typically your end users or your business partners, do not want to wait multiple seconds or even minutes for an analytical query to finish, right? Hence, again, latency becomes important. We have all read multiple stories that as the page load drops, basically the amount of time a page takes to load up starts increasing, then amount of users start dropping on the other end, right? Hence, the latency of these queries needs to be in milliseconds so that it has becomes instantaneous analytics, and that is the second pillar. The third pillar that comes onto is concurrency, right? Since you are opening up this analytics not just for your internal users, which is what the traditional analytical systems are designed to do, right? But these analytics are then being given or handed over the power to your end consumers or your business partners, right? Which are multitude in number. Consider the example of Stripe here, which has multiple million of merchants who can at any point of time look at their dashboard. And similarly, if I'm talking about LinkedIn, they have close to 1 billion users. Each and every one of them can open up the app concurrently, look at this data app within the LinkedIn app, and figure out what does their profile views look like, right? Hence, the system needs to be scalable, not just to handle single or tens of users, but on the order of thousands or even millions of concurrent queries, right? And these are the challenges associated with real-time analytics, right? Which are not so much associated with typically when you're doing with internal analytics. Again, repeating for the sake of brevity here, the data freshness, the query latency, and the concurrency, right? You want to be, most of these systems are on the left hand side or on the middle. However, when you're talking about real time analytics, user facing analytics, customer facing analytics, you want to be on the right hand side of the paradigm, right? Which is what Uber, Stripe, and Razorpay are doing, right? With the couple of use cases that we saw earlier. What is the way to achieve that, right? Again, taking a step back, historically, this was done over using a set of technologies, right, which were designed for batch processes. You have a transactional system on your left hand side. You typically run a batch ETL job looking at the last updated transaction timestamp on the table, fetch the records on T+1 every hour, every a few hours, etc., and dump that into a data warehouse where you would have internal dashboards hooked up onto these for somebody within the ecosystem to be able to gather insight, right? So the process of going from an event which has happened within the real world or a digital event to be able to act on that insight was a huge pipeline in itself, right? Which can take hours to days depending upon how fast do you run your pipeline, so on and so forth, right? What we saw was adoption of this simultaneous pipeline, which we refer to as a real-time data pipeline, right? In this case, these systems were replaced one by one, right? So in this case, you had an event store. So, and as soon as an event or transaction is happening on the real world, you're able to simulate that using an event store, push that out further to any streaming ETL layer primarily. And then you want to host that or save that data within a real-time database, and then you want to power these data apps within your core applications itself, right? Which are let's say micro data apps within your core app, giving the power of insight directly to your consumers or to your business partners, right? So simultaneously, as there was a batch pipeline, there was a rise of what we call as real-time data pipeline, right? And the proponents of these were primarily this tech stack, as you have seen, right? And we'll see this tech stack across the rest of the three case studies that we are going to talk about, right? But what Kafka did was it democratized the event store, right? It reduced the cost of producing an event as low as possible. So if you have an digital event that you want to simulate, you would straight away go to Kafka protocol or the Kafka API. And on the other hand, if you want to perform some stateful transactions or stateful stream processing, if I may, on that particular event, modify it, do ETL, move it from point A to point B, perform some business logic. That is what was democratized by Flink on the other side, right? And then finally, you have Apache Pinot. So Startree is the company behind Apache Pinot. Apache Pinot is the open source project, and what Apache Pinot is trying to do is reduce the cost per query, right? And it naturally fits into this ecosystem because Pinot as a database is designed to be able to ingest data in real time from Kafka directly and handle exactly one protocols, and it does not need any other ETL layer per se, right? Hence, this is the stack you will see commonly across the three case studies that we will talk in further, right? Before I move on to talking about case studies, that is Uber, Stripe, and Razorpay, just want to reiterate the points that we have discussed, right? So that is sort of cemented in our heads. We have seen a rise of data apps within which are helping give the insights back to their users, partners, etc. There are certain challenges with the existing data stacks in terms of primarily the data freshness, the query latency, as well as the concurrency. Due to the reason for which to tackle that, there is a birth of another stack. We can call that as a KFP stack or Kafka, Flink, or Pinot, right? Each taking up a part of that responsibility and trying to sort of make it very, very easy for you to move from a batch based system to a real time system and give the power back to your end users. Having said that, we'll just quickly move on to the use cases, right? And we'll go deep dive into all three aspects here. We'll start with Uber. Just to give you a quick snapshot of what the tech stack at Uber looks like here primarily, right? So we'll focus on the real-time data platform. So you can see exactly similar to what we have been talking about. The real-time data platform is powered by a mix of Kafka for doing their event streaming, event messaging, and then they have Flink for their real-time data streaming, and then they use open source Pinot for primarily serving low latency queries either within their core applications, both Uber Eats, as well as for multitude of their internal applications, right? And they having a real-time data platform does not absolve you of having a batch-based system, right? So they do also have a batch-based data platform, which of course includes a Spark, Presto, Hoodie, so on and so forth, right? And the data being stored in a data storage. But we'll focus on the real-time data platform. So the KFP platform strikes again. We'll focus on two particular use cases. The first of which is what Uber calls as a health line application, right? So what is the power of this application is primarily Uber does a lot of code changes to their core applications, right? And they have deployments going almost multiple times at a day. What they wanted to do was have a very, very reliable way to be able to do something what they known as crash analytics, right? If they release a new version of a particular Uber application on any of sort of devices, they want to be able to quickly pinpoint what is the health of that particular application, what is the health of the users using that particular application, the newer version on a particular set of devices, so on and so forth, right? And for this, it needs a real-time stack, right? Let's say there is a bug in the recent deployment which Uber has done. They cannot wait for an ETL pipeline to finish and then figure out, okay, bunch of users are facing issues, right? Hence, what happens is in this simulated flow is basically whenever they have a telemetry which gets collected from their mobile application or the app which is designed on the phone, it moves to a Apache Kafka as a layer. It passes through again a Flink for certain piece of transformations, and then is finally ingested using into Apache Pinot, right? And then they use multiple analysis on top of it in terms of what is the app health looking like for a particular geography of users, for a particular iOS, like Android, Apple, etc., etc. Apart from that, what are the session health looking like, how many active sessions are there, so on and so forth, right? This earlier stack was built out actually using Elasticsearch, which has actually been moved on to Apache Pinot, and they've seen significant savings, right? But primarily the stack remains the same KFP stack, Kafka for real-time telemetry coming from their mobile applications, Flink for certain tagging of this data, right? Additional tagging which they need to do for that particular data, for that telemetry data, and then finally getting ingested into Pinot, which is then sort of slice and dice by their internal teams. The second use case is more on the observability front. So tracing is basically if you want to look at spans or traces from within a particular set of codes, You what they do is they use open telemetry here. So they have open telemetry collectors as well as a hotel collector to be able to go ahead and push these traces from their code, right? Again, this is for their internal use case primarily, to be able to look at what are the spans across the uh, code bases, which particular set of lines, or for a to be able to trace each and every request end to end within a particular system of Uber application, right? They use this tracing system, which is again actually built on very similar stack, right? So each and every trace ID that is generated from their code base is pushed via an hotel collector onto a Kafka layer, which is then ingested onto Pino, and then they have internal UIs for them to be able to go ahead and uh, do developer debugging, right? Basically providing a trace ID to figure out, or a request ID to figure out what does the trace for that request ID look like, looking at the aggregates of what does a request in total look like, how much time is it taking, what is the average time, peak time, what happens when you simulate the load, etc. Right? Again, this has been, if you can just look at the scale here, primarily these are 3 million spans that are ingested across their complete uh, code base per second. The peak ingestion rate is 3.2 Gbps, and the total footprint just for 7 days in this case is close to zero point 0.6 petabyte, right? And all of this data is moving in real time, because and within from Kafka and Pino, right? Again, because you cannot wait if there is a issue with the certain code base, you cannot wait for a long time to figure out where is the bottleneck if you want to start scaling up your systems, or figuring out if that there is a bug, right? That is a huge revenue loss for these systems, even figuring out a couple of minutes late, right? So some of the metrics that they track for both of these applications are basically mean time to discovery, which is what they were trying to reduce in either one of those cases. Taking this slightly ahead, so what Uber has done across last 4 or 5 years is has actually consolidated multiple use cases for a variety of their data systems onto Pino, right? So, for example, the health line ecosystem that we talked about was initially done using Elasticsearch, has been moved on to Pino across 2021-2023 timeframe. Similarly, the logging framework or the tracing that we talked about, right, was also done using Elasticsearch, then using ClickHouse, and then eventually moving into Apache Pino, right? Just for the real time nature of being able to ingest that data in real time from Kafka and then push it or dump it into Pino and perform aggregations on top of it. AresDB is an internal database that they have been able to replace using with the ability of doing joins within the system. And similarly, MemSQL for certain key value lookups, which are important, they have pivoted back to Pino. Just to give you a quick scale of what all of this infrastructure is running at, they process close to 14 trillion Kafka messages per day, right? Which is an enormous amount of scale. Uh, Quite frankly, baffles me at will as well. And there are 5,000 Flink jobs running in parallel trying to process these 14 trillion messages. And the amount of data that is sitting on Pino right now is close to 20 petabytes across multiple clusters. And they run 600 million queries on Pino, right? Which is, I think, close to multiple thousand queries per second, which is again, it is not just about running these queries, but these queries are run within their core applications, which provide insights to their users as well as their driver partners, or their within their Uber freight as well, right? So just the scale of this is enormous in terms of being able to support the enterprise load from the KFP stack per se. We'll take a step ahead and quickly look at the Stripe use case. So we know what Stripe does. What we look at is primarily one of their largest use cases, right? So just to give you a context, today any transaction that happens on Stripe across the globe moves through this particular pipeline, right? And the pipeline is actually very similar to the KFP pipeline. So any transaction that you do moves through a Kafka layer. It is actually again moving through a Flink layer for certain tagging, and then is eventually distributed or ingested onto Pino. The use case here is powering merchant dashboards, right? So these are the dashboards which anybody if has used Stripe, when you open up Stripe at any point of time, you see these bunch of charts and graphs, right, which are primarily associated with the business health that the merchant is having, right? What does my MRR look like? What does my ARR look like? How many invoices are pending? how many invoices are scheduled or due, so on and so forth, right? So they have these bunch of very important metrics, or what they call as merchant dashboards, which are powered directly within their application, right? And again, these are millions of merchants who are logging into the platform, and this is the first screen that is here with that they see, right, which are insights which are associated with their business. And hence the scale at which this is running is close to 20,000 queries per second. And yes, these are analytical queries, not transactional queries. So having 20,000 analytical queries is a fairly large number, with a P99 latency of less than 70 milliseconds. And yes, that is milliseconds again, right? And this is the latency for any aggregation that they run on top of Pino, right? There is S3 as well here into the mix, which is basically for the historical data, right? So there is certain data which is coming in real time from Kafka, and then they have historical data. So Pino actually does support Lambda architecture. You can ingest this data coming in from batch data sources like S3, ADLS, even Delta Lake, and primarily also get the mix and match that data from a real time system like Kafka, Kinesis, and then be able to present an overall picture here. So apart from the primary merchant dashboards, Stripe also uses this for multiple other use cases, right? So again, looking at the customer facing analytics. So in Stripe's case, their customers are primarily their merchants. So they have this Stripe dashboards, they have this billing analytics, and then primarily even the developer analytics, right? So Stripe is used famous for their APIs and how well their APIs are used across the ecosystem, right? So each and every API call that you made is logged, and the analytics being driven on top of how many API calls were made, what is the success rate, what was the average response rate, which is again available to each and every developer, is powered by the same KFP stack primarily. And then they also use this data or these similar tech stack for certain internal analytics as well, right? Basically for their risk dashboards, for their financial data reporting, for their security tools in terms of what does the access policy look like for a certain product, for a certain system, so on and so forth, right? Because again, if there is something going off, they need to be able to identify that very, very fast rather than wait for a pipeline to finish or wait for an analytical query to finish, because the impact to the business is pretty high. Just to again give you a quick snapshot of the scale at which this is running, right? They push close to 80 billion Kafka messages per day. And this is pertaining to only the use cases that we are talking about here, right? Not in general. The data in Pino is more than 1 petabyte at the moment. And the amount of queries run per day is 1.5 billion across multiple Pino clusters, right? Which, to just to put in context, would be around 30 to 40,000 queries per second. And again, these are analytical queries, right? Providing insight right in the palm of Stripe merchants, so they can take this informed decisions primarily. Moving on to the last subset or the last use case for today, which is Razorpay. Just to set up context, what is Razorpay? So similar to Stripe, Razorpay is the biggest payment processor for digital payments back in India, right? So most of the digital payments across multitude of merchants go through a Razorpay network. And coincidentally, Razorpay also uses the same stack, which is Kafka, Flink, and Pino for a couple of use cases, right? One use case is very similar to what we looked at for Stripe, right? Which is the merchant dashboard. So Razorpay also has a set of merchant dashboards, which is then primarily looking at all of these business metrics for their millions of merchants as well, right? There's something else uniquely which they do, which is some of their microservices require this data in real time, right? And this data is called as success rate. Basically, since Razorpay is a payment processor, it allows you to, or allows a customer to be able to pay via multitude of payment options, right? Credit cards, debit cards, UPI back in India, then pay now later scheme, so on and so forth, right? What they want to do is in real time be able to detect what is the success rate looking like for each and every payment processor. So let's say in last 1 minute, if 100 transactions went through for HDFC Bank credit card, how many transactions of those were successful? And that is what helps them calculate what is known as success rate. How they use this information is primarily when a new user comes into pay, they dynamically shuffle this order of options available to the user depending upon the success rate in the last 1 minute, last 5 minutes, for a particular payment category, right? This allows the success rate to be higher for, of course, users trying to directly nudge them to use a different payment option, as well as it allows them to give a warning across that particular payment processor, right? We have seen a failure rate of 0.2% in last 10 minutes. So you would be advised to use some other system, so on and so forth. So this becomes very, very powerful for them, because for them, if a user has reached the last leg of the journey, they want to very well make sure that the payment goes successfully, right? And not sort of hamper their journey then and there itself. Again, if you look at the high level architecture of what their system looks like, what you will see is they have a core RDBMS on the left hand side, which is where the transactions are happening. They do change data capture, which is actually they use Debezium for that and push that data onto a Kafka layer. And then that Kafka is pushed onto Pinot. They use, instead of Flink here, they use Spark streaming, but the idea is pretty much same, right? Kafka is used as a event store. Spark streaming used for stateful event processing, and then Pinot becomes the system of choice for storing that data in real time and then used across multiple of these services, right? Either via a Trino layer for internal analytics or via these third party applications within their ecosystem, right? These are just, again, to give you a final thought of what are the other use cases. They use it for a couple of other use cases for microservices supporting these payment flows, right? So they perform fraud analytic checks as well. So when a transaction is happening for a particular payment, they make these quick checks on, okay, what is the transaction rate looking for that particular customer in last 10 minutes? How many transactions has the customer cancelled? So on and so forth, to make sure that the transaction is valid. If not, they flag it off and move it onto a manual bucket. And then the again, since the data is coming, all the transaction data is coming in real time to this system. This helps them use the same data for their internal analytics, internal risk systems, as well as detecting anomalies, right? Anomalies in terms of their system, is it performing well or not? Anomalies in terms of looking at what is their API rate, API response time, so on and so forth. So this is, again, just a quick snapshot of what the numbers look like for this system today within the Razorpay ecosystem. It is, again, greater than 5 million queries per day, 30,000 transactions happening within the system. And these are real transactions which somebody has done in India using varied payment ecosystem, right? And the total data size being across 30 terabytes or so within the entire cluster. Just want to quickly recap on a couple of points that we discussed today, right? Uh, Primarily, what we started with was there are these Uber, Stripe, and Razorpay are primarily powering these digital native experiences or data apps within their core applications itself, which are helping provide insights to their end users directly, right? And there are certain challenges associated with being able to do it using the traditional tech stack. And hence the birth of a tech stack like primarily Kafka, Flink, and Pinot, right? Just to recap on the quick use cases, we saw Uber uses it for Healthline, which is their crash app analytics. It uses it for their restaurant manager app, and it uses it for their entire observability. Similarly, what I quickly talked about for was Stripe. Stripe uses it for their billing analytics, for their merchant dashboards, for their internal risk monitoring. And then finally, moving on to Razorpay, which is a payment processor in India. They also use it for measuring what is known as a success rate, which helps them allow to dynamically tweak the payment processor options. With that, I'll take a pause here. If you want to just connect with me, you can connect with me on LinkedIn. Feel free to join the Pinot open source Slack as well. You will find lots of help there and a lot of some of these conversations which are ongoing, right? In terms of people trying out these use cases, trying to see how does it fit for them. And then finally, you can connect or reach to me and Startree for any help that is needed. Thank you.